So hey everyone, in this video we are going to understand how can we deploy a backend application. Alright, so we are going to get started with the deployment process. So far we have completed the application, so now we are currently been running it locally within our machine. We have been working on this repository which has certain features like I'm running on Node.22 and a specific version of MongoDB and Redis and also the macOS. Okay, and if I just push this code and if I give to my fellow developer to pull this code and run on his or her machine, it might not function the way how it is functioning in our system. Okay, because there's a lot of system incompatibility. Okay, I'm using different versions and there is different versions installed in his or her system. Okay, so due to this he or she might face some errors while installing this particular application. All right, so currently that is the main problem when it comes to deployment. Okay, even though if I deploy this application to a virtual machine like on EC2 AWS, so there also it will be running on a complete different OS and it will have a different system specifications. So that is the first challenge which we actually face while deployment, and I'm going to address that particular problem within this video. So let's get started. So far we have developed our application which is actually running well and fine. Okay, so we are having certain specifications, right, that we are actually running on. So that is on, let's say, Node 22 and Mac OS. So in my case you might be running it on Windows, and we have other specification as well, like we are running PNPM as I also mentioned. So these are all the requirements that we need to actually have in order to run our particular code. Okay, so now let's say I want my fellow developer to also contribute to my code. Okay, so what I do is I just push it to a repository on GitHub or Bitbucket. So I just push my code, so I just push it and then my fellow developer will do the pull, and then he or she will try to run it on his or her system. All right, so the problem here is his or her system might not have the same specifications that are there in my system. Okay, so basically they will be having, like, let's say Node 18 and also let's say Windows or Linux, and instead of PNPM they might be using YARN or just NPM. So these are all the issues that we might face. Okay, so due to this incompatibility we might face some errors while running this code. So that is the first problem. The second problem is that we need to have a set of instructions on what exactly this particular code should be run. Like, let's say this is running on port 8080 and using PNPM and all of that stuff, right? And also the command to start the development server, that is npm run dev. Okay, and so on and so forth. So all of these instructions also need to be given. All right, so these are the two problems that currently we might face during development, or it can even be when we are deploying on a virtual machine. Basically, let's say your virtual machine is running on Ubuntu and having a completely different specification. Okay, so if you just try to deploy your code just like that, it will not actually run. Okay, so these are all because of these specification incompatibilities that we usually occur. So that's where containerization comes into play. Okay, so containerization, and one such popular library that helps us solve this problem is Docker. So Docker is the most popular library and we are going to implement within this video. So basically what containerization means is that we are not only going to deploy our code or push our code. Okay, so we are also going to containerize the whole environment. You see this whole thing except the OS, because that's a very heavy object, so we can't do that. So before I create a container, we build something called as an image. Okay, so based on this image we spin up containers. Okay, so we can just spin n number of containers, and whichever port which is exposed within this container I'll be able to access within my system. Okay, so basically each container will have its own file system. It's like a completely new computer. Okay, we'll be having all these instructions how exactly a container must be run. Based on that, when you start a container, your application will be running inside that. Okay, and then our ports will be exposed, which I'll actually come to that when we are practically doing it. Based on that we can access our application. Okay, so based on all of these specifications it will use. Okay, and you might be having a node version, like let's say this is actually, let's say this node 18. Okay, and I might be having node version 22, even though I'll be able to access this because this is running inside the container. As I told, a container is a completely isolated system, and let's say this application is running on Ubuntu, basically the OS of Linux, and I will still be able to access it because it is running inside this container, and just by exposing the port I will be able to access it outside. Okay, so once I have built this entire image, okay, I can just ship this. Okay, basically I can just push this code basically into another secure place called as a Docker hub, just as how we push our code to GitHub, right? And then our fellow developers will take the pull and start developing. The same way we also have another centralized repository system called as Docker hub. Okay, so I can just write Docker hub. This is similar how we can push our images. Okay, so we cannot push containers, so we push the image and then we take the pull of that image and then run containers locally within our system. Okay, so even though we are having a completely different specification, due to this completely isolated environment, having the necessary tools and specific versions that are actually required to run this particular code, we will be able to run without any errors. Okay, so this is the main concept about containerization, and Docker is one such tool that helps us do that. Okay, so this is the most popular technology which we will be learning it practically. All right, basically, if you might have a question that if our code is running inside the container, which is let's say running on port 8080, how can we be able to access from outside this container, basically from our system, our laptops? Okay, so basically this is the concept of port mapping, where I expose the port of this container, so basically which is running on 8080, I can expose this to be running on 8080 on my own system, on my laptop. Okay, so using this particular port I will be able to view my application. All right, so this is how we can access the ports inside the container. So I hope you have understood the actual problem, okay, during deployments, and how Docker is one such underlying technology can help us eradicate that problem. All right, so let's go ahead and install Docker. So you can just go to docker.com, and this is the official page for Docker, by the way, and only thing we just need to do is download the Docker desktop version. Okay, so you can just click on this button and select your operating system. So currently I'm working on Mac, so I can just click on download for Mac and install it. Okay, so once you install, you will have an interface similar to this. All right, so I can just show you that. So once you download and install, this will be the interface which you will be having a look. So we'll be having a sidebar over here with all the containers. So these are the existing containers with their respective ID, which image does it belong to, and what port is it running. So these are all the actions. Either we want to run the container, stop. So this is a complete user interface. We can also do this in terminal as well, which I'm going to show you after this. And then these are all the images that I have, and we need to make sure that this always runs. All right, so this is the daemon for Docker. Basically this will run the Docker server. Okay, so only if this is running, we will be able to run Docker commands on our terminal. So now I have opened my terminal in full screen. So now that our Docker daemon is running, so we can just type in Docker and just hit enter. So you see that we are getting a list of commands, which means that our Docker is successfully installed and ready to use. All right, so now we can just get started. So let us start by containerizing our whole backend application by writing a Docker file. Okay, so basically we just need to go to the root of our folder and create a Docker file over there. All right, so you can just click on this and create a Docker file with no extension. Okay, so once you have the Docker extension, it will look like a container like this. Okay, so which means that this is the actual Docker file. So this file will actually be run whenever we want to build an image of our backend. So while creating an image, it will run all of these commands that we specify within this file and build that image. Okay, and based on that image, we can run multiple containers. Okay, so basically our backend project is based out of Node.js, right? And we want Node.js to be installed inside our container, because our container is isolated and it will be nothing inside that. Whenever we start a fresh one, it is like a new system, new computer. So we want to first thing install Node. Okay, so we can just specify the base image. Okay, so we can just write from. So basically this has a complete different syntax for Docker file. So we need to specify what is our base image, so that is Node. Okay, so basically when you just install Node, we just don't want to install the heavier package. We want a lightweight package so that we can just ship easily and it will be easy to install within less time. Okay, so we can use the lighter version. So to use the lighter version, we can use the Node::Alpine. Okay, so this is the lighter version of Node. So this is actually sufficient in order to run our backend project. Okay, so based on this image, wherever I run my container, either in my system or my colleague's system, so this is the Node version that will be picked up. So the next step is to specify our working directory. where all of our files should be copied in. Okay, so our container is currently empty, so we want to create a folder where all of our actual source code will exist over there. So we can just specify work dir, and this will give some IntelliSense. By the way, if you have the Docker extension installed, so we just need to install it within /app. Okay, so this is just a standard, you can just give this any name, so all of our code will contain inside that. Okay, so now what we just now need to do is copy our package.json, because that's the first step, right? So we want to install all of the packages that we have to run this project, so by doing npm install. So first thing is we want to copy the package.json, so we can just do that by saying copy and then specify package.json. Okay, so package and package log, anything we want to copy it, so we can just use a wildcard of star.json, and then we just need to specify the destination path that is inside our container where it has to store. So that is at the root. Okay, since we already given work there at /app, so we can just do /. Okay, so it will copy the package.json over there along the package log because of this wildcard. So now we can just do a npm install. So this is the command when we want to run when building a image. Okay, so we can just specify run and then npm install. Okay, so in this case we are using pnpm, right? So we can just do a pnpm install over there. So once all of our packages are installed, we now want to copy our entire source code within the containers app directory. So we can just use the copy command again, and now we just specify the actual path, our host file, to the destination file inside our container. So we can just specify a dot, which means that within this current directory where the Docker file is, whatever the files we have, we want to copy that inside the container. So we can just specify another dot. So we don't have to specify ./app because this is the actual working directory. Inside that we are currently located inside our container, and it will copy all of our source code inside that. Okay, so that is the reason why we specified 2 dots over here. So the first path is where actually all of my source code is present, and we want to copy that to our destination path where all of our files will copy inside the container. And next we want to do a npm run build, since this project is based out of TypeScript and we just want to build our application and then serve our files. All right, so we can just do a run npm run build, and once all of our TypeScript files are compiled, we just want to run the application, because that's not the job of an image to do. So that's the job of a container to do. Okay, so currently we are just building the image. Whenever we run this file, we just want to build the image, so we just don't want to do that. So one thing which we certainly want to do is to expose our port. Okay, so our container will have certain ports that are running inside that, so we just want to expose that so that we can run within our host machine, that is the machine which I'm running this system. Okay, so that is why we just want to expose. So we use that using the expose command. Okay, and then specify the port, so that is 8080 because that's the port that is running this particular application. And then finally we want to specify a command whenever we run a container based on this image, so that command should run. So basically that should start our application. So what is our start script? When we look into our package.json, so that is npm start, right? Because we want to start the production version of it. So that is why we just run the command. So we write it within cmd and then specify within an array like this, so that is npm, and then separate that by start. So here we just give it in an array like this. Okay, so don't get confused within this run command and the cmd, because run is while building the Docker image, and one is to run the container after creating the image. Okay, so when we run a container based on this image, so this particular script will run. All right, so this is our simple Docker file. So I have just added some comments just for some easy understanding in case you found this a little difficult to understand. So we can now save this file, and we can create another file in order to ignore certain folders and files within the process of building a Docker image. Okay, so just as we have a git ignore which will actually ignore while pushing our code to GitHub, so we can create a similar file just for Docker in order to ignore those files during the build process. Okay, so we can just click a file over here called as .dockerignore, similar to the git ignore. So all right, and over here first thing is we want to exclude our node modules. So we do not want to copy our node module since this is very heavy object, and then we do not want to copy our dist folder. Basically this is the folder once we compile all of our TypeScript code. Okay, so we can now save this and go back to our terminal, and finally let us create an image out of this Docker file. Okay, so I'm just going to expand this, and so now we can do a Docker build basically to build our image, and we can specify a tag which is actually optional. So it is actually required whenever we want to push our Docker image to Docker Hub. Okay, so we can just specify a tag of -t, and we can just give this of any name. Let's call this backend, and now we just need to specify the path where our Docker file is existing. Okay, so it is currently at the same level as where I'm running this particular command, so I can just put a dot over here. Okay, so now if I just click on enter, so this will go ahead and build all of my files, okay, and create an image of this backend name. So here it says it cannot find the package pnpm. Okay, so right before we install all of our packages, we can also install pnpm globally. Okay, so we can just do a run npm install -g. We can install this globally inside our container and specify pnpm. Okay, so npm will be by default installed once we have our node image installed. So now we can save this file and rerun the same command again, and let's see now if it works. Okay, so now all of our packages are currently installing. So basically there are 11 steps, 8 of them are currently executing, and this is the build time, and let's wait for it until it builds. So you can also see the logs over here, what all while running these commands these logs appears. So now our images are completely built. So you can just verify by doing a docker image ls, and once you hit enter, so this will list all of our images. So currently I have a lot of images. So currently you see that about a minute ago I created the image called as backend, and this is the ID of it, and this is the size, that is 337 MB. So these previous ones were all just for my testing. All right, so we can just focus on this particular backend image. Okay, so we can just also verify within our Docker desktop. So when you click on images, so we should be getting our image over here. Okay, so that is actually we need to refresh this, and it is at the last over here. You see that our image name is backend, and this is started 2 minutes ago. So now that our image is built, we can now go ahead and run our container, okay, based on this particular image. So to run a container, so we can specify docker run. Basically this run command is used to spin up a container. So first thing which we need to specify is the port where our application needs to run. Okay, so we can specify by saying -p, and here we just need to specify 2 ports. One is the port where our actual application is running on our host machine, and one is inside the container where we have exposed the port, that is 8080 if you remember over here. So this will be the port that is be exposed. So over here we can specify 8080, so that is the port on our machine, and the port inside the machine, that is 8080. Okay, so this is called as port mapping inside Docker containers. All right, so next thing is we just need to specify a name. So name we can just specify right before the port by saying --name. We can just give this a name of to do app. So this is the name of our container, and then we need to specify the image name based on what this particular container needs to be spinned up. Okay, so the image name is backend. And now let's run this command. So whenever you have an existing container with the same name running, so it will give us a conflict. Okay, so you want to delete the previous container or give it a new name. Okay, so containers always should have a unique name. All right, so I'm just going to delete the previous container which I had during my testing. So we can just do a docker rm to remove something. So we want to remove a container specifying the name, that is to do -app. So this will go ahead and remove the container. So this is the container name that it returns us. So now we can just rerun the same command again. Okay, so now this should actually run, and right away I'm going to say that our application is going to fail because we are missing 2 things. One is our MongoDB database that is running on its own port, and one is Redis, which we haven't configured inside our container to be running. Okay, so these are the 2 different services that we need to run. So we need to create 2 more containers. One is for the MongoDB and one is for Redis. Okay, so totally we'll be having 3 containers, and with the conjunction of these 3 we will be running our application smoothly. So let's go ahead and create a container for MongoDB. Okay, so for MongoDB we don't have to write a separate Docker file and then spin up a MongoDB container, because there is already an official image in Docker Hub, so that we can just reutilize that and then create a container out of it. Okay, so if you just go to Google and just type in Mongo Docker, and this is the official image where we can just take a pull. Okay, so over here something went wrong. Let's refresh. So this is the Docker official image, okay, which is publicly available. It will just check if we have a container named Mongo. It will use that. If not, it will just pull from the Docker hub. Okay, so let's go ahead and do that. So we can do a Docker run, and we need to specify port as I told. So the default port of MongoDB, as you know, is 27107. So giving it a port of 27107 and map it to the same port inside the container, so 27107, and then give this a name of Mongo, and also I'm going to call this container Mongo, so give it dash name Mongo. And if you want, you can also run this in detached mode, okay, which means that this will run in the background and it will not show any logs over here. So you can just do -d, which stands for detached. Alright, so this should be name, and I misspelled it. Alright, so now we can go ahead and run this container. So if I just click enter, so actually I just stored my Docker daemon, that is why it's giving me this error. So always you need to make sure that this is always running. Okay, so now if I just do the again, my container was previously running before I was testing it. So now let's do the rerun the same command. So now that I have removed the Mongo container, now see that it since I have run this in detached mode, it doesn't shows all the logs and stuff. Okay, so this will just return as the container ID. Okay, so if you want to look at the logs, we can just do a docker logs and then the container name, so that is Mongo. Okay, so now you hit enter, so these are all the logs. Okay, so if you just have a look at these logs, so somewhere it should be written success. Okay, which means that our MongoDB is successfully spinning up. So now if we have a look at our containers, we see the container named Mongo and it is mapped to port 27107, and we just started it 1 minute ago. Okay, so now we have two containers that are running, one with port 8080 that is exposed, that is our app itself, and then another container for MongoDB that has a port of 27107. Okay, let's delete the previous container. So I'm just going to do docker rm to do app. Okay, and then now I'm just going to rerun the same container back. So had it somewhere here. Yeah, so let's wait for it. So now you see that our server is successfully running on port 8080. Okay, just because we had spinned up our MongoDB container. Okay, so we had exposed the port of 27107. So if you just have a look at our DB, so over here you see that we have described the port over here, that is 27107 if within our example file over here. Okay, so that is the reason why it is able to access it. Okay, so now within my postman, I'm just going to register a user. So if I just register a user, I should be able to register. But it's not able to register. The reason is we are getting a MongoDB connection error. Okay, so basically when we have two containers, so they cannot communicate with each other. Okay, even though their ports are exposed. So for that we just need to resolve the host of the the MongoDB container, and then use it within this particular container, that is to do app, where our application is running. So for that we just need to go to our database file, and over here we just need to replace this host with the host that is running our Docker container for MongoDB. Okay, so if you just have a look at this example file, so currently our host is localhost. Okay, so this is not exactly the host in MongoDB, so we just need to use that host and then replace it over here. So every time we spin a new container for MongoDB, it will have a different host name, it will always not be the same. So that is why in order to dynamically get the host name, so we have a special code to resolve the host, that is host.docker.internal. Okay, so this will internally resolve the host and then use this variable dynamically. Okay, so now if I save this and make sure this is, you are actually using the real.env file, and this is just the example. So now that we have changed something within our code, we need to rebuild our image. Okay, so here we can just do a docker build -t backend and dot, same as before. So this should get relatively quicker because it will be all cached. You see that this is all cached over here, so which are all actually cached, it will just pick up from the cache. If not, it will just rebuild. Okay, so this time it is very quick. Okay, so let's wait for it. So it took just 18 seconds this time. So now let's go ahead and run our container. So first of all, let us remove the old containers by doing docker rm to do app. Okay, and now let's run our new container, and let's wait for it. So now our server is running on port 8080. Okay, so now if we go back to postman and now try to register a user, So you see that now we are successfully able to register, okay, just because our connection to MongoDB was successful. Okay, so this is how you can use MongoDB in conjunction to your backend project, just by resolving the host name. Okay, so make sure that this is the actual thing that you are doing, that is host.docker.internal. Okay, so now we have integrated MongoDB inside our Docker container. So one last step is to integrate even Redis. All right, so currently I've just commented out the code just to just do testing for MongoDB first and then go on to Redis. So I've just commented out wherever I've used Redis. Okay, so let's now uncomment all of these up. So this time if we just try to rerun the container, we should get a Redis error because we do not have any Redis service running. Okay, so we can also spin up a third container to run Redis. Okay, so I'm just going to create another terminal over here and going to run another command to spin up a Redis container. Okay, so we can just do a docker run. Okay, so just like MongoDB, we have another image for Redis as well. Okay, so if you just search for Redis docker, and you will find an official image for that. Okay, so right here, and you can just have a look at the commands whatever they are using, and yeah, so this is the image where you can just do a docker pull Redis or docker run directly this container name, this image name, and then it will create a container out of it. Okay, so we can just do docker run. First let's give a name of Redis and give it a port of 6379 because that's the default port that Redis actually runs. So 6379 and mapping it to 6379, and I'm going to run this in detached mode and give the image name Redis. Okay, so now if I hit enter, so we already have that, so let's first remove that. Okay, so now our Redis container is running. So if you want to have a look at the logs, so you can just do docker logs and then give it your container name Redis. So you see that it says it is ready to accept connections. All right, so inside Redis we also need to configure using a password, right? If not, it gives us a password error. So if you have a look at our .env file over here, we are also giving a Redis password also over here. Okay, so along with the host and the password. Okay, so to set a password, we need to use the Redis CLI inside the container. Okay, so the first step is to get inside the container and run commands over there. Okay, so we can also get inside the container by using the docker exec command. Okay, so this is used to execute something in the command inside the container by using -it, which stands for interactive mode, and then give it your container name Redis, and then what commands do you want to run, what do you want to run inside that. So we just want to open a bash terminal. Okay, so if you just hit enter, so you will see that this is we are currently inside the container, so we can now run in bash commands over there. So if we just do a ls over here, this will actually give us a completely different file system. Okay, so you see that currently it's empty, we do not have anything inside that. So we can now go ahead and do Redis CLI. So this will open a CLI, so it looks something like this at port 6379. So if we just do a ping, it will return us with pong, which means that our Redis CLI is up and running. So over here we just want to configure the password. So the command for that is config set require pass, like this, and then give it your password. So I'm just going to set this to password. Alright, and now if I click on enter, it says okay, which means that our password is set. So now we can just exit from the container by saying exit. Okay, so this is how you can get inside the container and then run commands over there. Okay, so now that we have added the logic to use Redis, okay, so we have just done some changes, right? So we just need to rebuild the image. Okay, so we can just do a control C, so this will stop the container, and we can just first remove the container saying docker rm to do app. Okay, and then now we can rebuild the image. So we can just do docker build -t backend and then a dot. So it has found something from our cache, so it will just pick it up. So if our package.json anything is changed, it will not use the cache. Okay, so now we have built our image, so let's rerun the the container based on this backend image. So let's see if our connection is successful. So over here the host name is Redis, but within our .env file we have set the host name to be localhost. So here also we need to give the host name as Redis. Okay, so now we can just save this, rebuild our container, and then try to rerun this and check if our Redis is actually connected or not. Okay, so I'm just going to kill this container and do the same process. So now I have 3 containers that is running. One is MongoDB, one is our actual application and one is Redis. Okay, so the problem here is these are all completely isolated containers, so they cannot communicate with each other, so they don't have any mechanisms. So for every container we'll have an IP address, right? So this has an IP, this has an IP, this has an IP. So there is no such routing mechanism such that I can route whatever I have within my file system to the other container. So this is actually not possible. So even if we trace the route, we cannot reach this container. So this is where Docker networks comes into picture. Okay, so what I can just do is I can place all of these containers inside one particular network. So I can just draw the network here. So this is the network. So this network itself will have its own IP address. Okay, so using this IP address, I will be able to communicate to other container by having a lookup to this IP address and then routing it to the appropriate container. All right, so for example, if I am connected to a particular Wi-Fi and if I expose my file system and another person who's also connected to the same Wi-Fi, okay, so he or she will be able to access my file system. Okay, so if I'm running anything on localhost, okay, so the other person who's connected to the same Wi-Fi network will be able to access. That is due to IP tunneling. That's the concept of that. Okay, because it is actually found a path to reach my system. Even though I'm running my application locally, my fellow developer or who's connected to the same Wi-Fi network will be able to access it. Okay, so of course we need to give it certain permissions and stuff, so without that it cannot work. So this is the same concept where Docker networks also works. All right, so each of these containers has its IP address, and through this IP address we will be able to communicate. So now Redis is running on port 6379, right? And even though my application is it's running on port 8080, I will be able to access this, okay, because it is under the same network. So I will check what is running on 6379 and I will be able to access that. Okay, so this is all about Docker networks. Let's go ahead and implement this. So let us create a network by saying network create and give it a name. Okay, so I'm going to call this to do network. Alright, so this will go ahead and create a network. So this is the network ID. So if you want to just verify, you can just do docker network ls. Okay, so these are my previous networks. So this is the latest network that I just created, that is to do network. Okay, so now we can just clear this, and now we can connect our MongoDB and Redis containers to this network. Okay, so we can just connect by saying docker network connect, and then give it your container name first, that is to do network, and then give it your container name, that is Mongo. Okay, so now if I hit enter, so now it is connected, and let's do the same for Redis as well. So okay, so now if we do a inspect, so we can inspect our containers also, by the way. So we can just do a docker network inspect. So this will give us all the details about the particular network, so that is to do network. So now if I hit enter, it gives us a bunch of details. So the thing which we need to see for is this containers over here. You see that this is an object with all the other stuff. We are interested in this name Mongo and Redis. Okay, so now these two containers are within this network. Okay, so now they can talk to each other because they are all under one IP address, and through that IP address they can communicate with each other. Okay, so now we can go ahead and connect our main backend application also that we built using this Dockerfile. So we can now go ahead and do a docker build -t backend dot, and once it builds we can connect this. Okay, so right before we connect, we also need to specify the network where it has to connect with. Okay, so let us wait for this. So now we can run our container by saying docker run and give it this name of to do app. Okay, and we can map the port, that is 8080 to 8080. Okay, and now we just need to give this a network. Okay, so we can just specify -- network and then give this a network name. So make sure this is the right spelling, so to do network and then backend. Alright, so now if I hit enter, so this should run our application, and now you see that our cache is also working. Okay, so our Redis is now successfully connected, and now our server is also running on port 8080. Okay, so now let's go ahead and test our entire application. So we have three services that are containerized. One is our entire backend, one is Mongo, and one is Redis. So all are under this network of to-do network, and now they can communicate with each other through the network IP address. All right. So now let us go to Postman and try to register a user and check if everything is working. Yes, it does work because user is already existing. So I can just put another user over here, and now our functionality, everything is working. So now we can go ahead and create a to-do. So we can just go to this create to-do API. Okay, so with the title and description, let's see if we can able to create a to-do. Yes, we are able to create. Now let's check if we can get to-dos as well. Okay, so we are also able to get all the to-dos as well. Okay, so everything is working nice and fine. So now we are fetching the to-dos from the cache as well, right? So we need to also test that. So when we go back to our terminal, we get some real-time logs as well. Okay, just as we were doing in development without containerization. So you see that we are fetching all the data from our cache, and these are all the some console logs that I had applied earlier. So now if I just click on adding another to-do, so I can just add another to-do over here, and now if I just try to fetch the to-dos over here, so now I don't find anything from cache. Okay, so it is null. So now if I just make another request, so it should now fetch from the cache. Okay, so cache found, and this is the values. Okay, so everything is like working fine. So the cache is because of Redis. So I just wanted to test that as well. So there is one problem we are currently facing. Okay, so whenever we stop containers and then bring them back, all of our data that are stored in MongoDB and Redis will all be not present. Okay, because the container stopped and then restarted. So that is the problem which we are facing. So there is one solution that we can come up within Docker is by using Docker volumes. Okay, so I'll just demonstrate how we can achieve that. Even though while we stop and restart containers, our data still persists. Okay, and will be served. So now we can just try to test that once again. So I'm just going to stop my containers. So I'm just going to do a docker stop Redis and Mongo. Okay, so now all of our containers are stopped. So now if I just start these two containers back, so I'm just going to do Redis start of these two, and now I can just run my real application, so which I can just do by saying docker start to do app. Okay, so our application is now running. So now if I just make a request to /API/todo, so here I'm still getting data because I had a volume previously when I was testing it. Okay, it was linked to the same container name to do app, so that's where it is fetching from. So when you try this, you will see that you will get this completely empty. Okay, since once you stop and start your container, it will, all of your data will be lost. So if you want to persist data, we can use volumes. Okay, so I can just show you how you can use volumes. So now let's take an example of this container which is actually running MongoDB, okay, on port 27017. Okay, so this is running MongoDB. Sorry for my handwriting. Let's say we store some data inside this. Okay, so we are having some data within our MongoDB container. Let's say for some reason our container went down. Okay, so we just need to restart this container up. Okay, so whenever we bring this container back up, so we have a fresh MongoDB database. So this is a completely new container. Okay, so you might be wondering, like, what is the data, what about the data that was there in our previous container? Obviously the data is actually lost. Okay, so this is the problem. Whenever we shut down, spin a container backup, whatever the changes, whatever the data we had is completely gone. So in order to preserve data, whenever we shut down and start containers, our data should be backup. Okay, so that's where Docker volumes comes into picture. So basically volumes is nothing but it actually stores somewhere within our Docker. Okay, so basically we cannot see, we cannot access those systems, so it stores somewhere basically inside Docker. So next time whenever our container goes down and when it comes back up, it will just check if we have any data related to this same container name. So basically we have this container name, let's say Mongo. Okay, so whenever we are spinning up with the same container name, so it will just go and pick up the data from this Docker. So it stores somewhere which we actually cannot access, and if it finds some data there, so whenever we spin up a new container, it will be fetch the data from there. So let's say for example we had 3 to-dos. which for some reason our MongoDB database went down. So the next time when we have to spin up the container back, so we can this will already be stored. So whenever it's down, it will, whenever we are starting a new container, it will just fetch the to-dos from our basically inside this hidden file system inside Docker. Okay, so that's the concept of Docker volumes. So we can just close this particular container and we can just stop all those 3 containers. So to do app, and also I'm going to remove them as well. So we can just do rm and this will remove these 3 containers. So now we do not have any containers running and nor do they exist. So now I just want to restart them. So using the previous command, in addition to adding the network as well, I can also add another flag for a volume. Okay, so basically volumes are nothing but it is somewhere, it is stored inside Docker, so that later in future whenever we stop and restart containers, it will pick data from that particular file. Okay, so we cannot access that file, it is stored somewhere in Docker, so it is somewhere hidden. So using volumes, it will fetch from that data and it will serve it. Okay, so when it comes to MongoDB, so we need to know which path exactly does our data store inside MongoDB. Okay, so when we have a look at the official Docker image for Mongo, so it stores in somewhere /data/db. okay, so this is the folder where all of our data is stored. So we can just use the same. Okay, so we can just provide a volume by saying -v, which stands for volume, and here we just need to specify our path. So basically we can just give this any name, like saying Mongo data. Okay, and separating that by a colon and then give it a path inside the container. Okay, so just as I showed you, it is /data/db. okay, so this is the command, and now if we hit enter, this will create a volume. Okay, so we can do the same for Redis as well. So we can search the same for Redis as well. So we can go to this official image and search for where exactly it is stored. So I can just do a it's over here :/data. okay, so it is just /data and nothing else after that. So we can do the same for Redis as well. So let's add a -v and give this name, like let's say Redis data, and then provide the actual place where the Redis data is stored, that is /data. okay, so now if I hit enter, so our volume is created for Redis as well. Okay, so now we can restart our container. Okay, so now we can just check if our volumes are actually working. So now when we hit this route API/todo, we are getting all the to-dos. So next time when I click on send, so this is going to fetch from the cache. Okay, so we can verify from the logs as well. Initially it says like cache found null, and then our cache is actually found with all of our to-dos. Okay, so we can just verify that. So we can just stop our Redis container. So I'm just going to open another terminal, and over here we can do a docker stop Mongo and Redis. Okay, so these containers are stopped. So now we can just restart these containers by saying docker start. Okay, so now Mongo and Redis are now up. So now we can just go back to our Postman and just try to send once again. So now it says cache is reconnecting because the password, every time when we restart the Redis, right, it gets deleted. So we need to give that a password as well. So let's quickly go ahead and do that. So now I have set my password. So now if I just try to send again, so I'm getting the cached one. So we can just verify that by going back to here, and we are saying that cache found, and this is the to-dos. Okay, so this is how we can use volumes, okay, in order to persist data. So whenever we start and stop or even kill containers and bring them back, our data will still be persisted, because when we have a look at the data where exactly it is stored within Redis or MongoDB, that is /data or /db.data, there exactly our data is stored. So next time when it's we are running our container, it will pick the data from that. Okay, so this is all about volumes. All right, so now next time whenever let's say when I'm developing the application, so I just make some change over here, like within the to-do controller or somewhere else. So whenever I save the file, we need to build the Docker image again. If you'd have realized, like I just made a change in my .env file or this example file, I had to rebuild my container and then start the container again. So this is a bit of a problem, right? Especially during development, if you want to see instant changes within your container as well. Okay, so that's where bind mounts come into picture. Okay, so basically we are currently binding the entire file structure basically over here into the Docker container where exactly this files are located, so that if I make any change within my files, so it will instantly be reflected in the Docker container as well. So this is basically called mirroring. Okay, so if I just change here, it will change there as well. So that is where bind mounts within Docker is a concept which will come into place. Okay, so let us go ahead and understand how can we achieve that. So whenever we are starting our container, the to-do app container, so we also need to provide a volume over there. Okay, this will actually monitor the file changes from host system to the container. So now let's say I make a change in my host machine. Basically I am running it on my laptop and not on a container. So like let's say on my index.js I make some change. Okay, so due to this change, the same changes will not be reflected inside the container as well. So if I want it to be reflected inside the container, I need to rebuild the same image. I need to do a Docker build. So this is the problem. Every single time I make a change over here, so I need to make it instantly reflect inside my container as well. Okay, so that's where Docker has a concept called as bind mounts. Okay, so the concept here is bind mounts. So basically what this does is it does mirroring. So if I have my index.js inside my container, alright, so the same changes whatever is I make on my system, basically when I save my index.js, so the same file changes will happen inside the container as well. Anytime I make a change, I don't have to rebuild the same image. Okay, so what actually we need to do is we just need to run this in the watch mode. So anytime change happens within index.js, so it should restart, basically node 1, the same concept, right? So without that we just need to stop the container and then restart it. So that's a problem, right? So we can just use node 1 instead of that, and we will also be practically using it. All right, so in order to construct a bind mount, before we actually start a container, we just need to give it a volume. So basically inside a volume, this is called as a named volume. Okay, so there are two types of volumes, one is named and one is anonymous. Okay, so I'll just come to that. So within named volumes, we need to specify the path of where our host machine or source code is actually running. So that is basically slash source or something. Okay, not source, or basically nodejs backend architecture if that is your folder name. And we need to mirror the same changes inside the container as well. So our container is running in the app folder, right? So we just need to specify slash app. Okay, so whatever the changes that we make over here will be reflected here. So we just need to separate this by a colon. Okay, so here we need to give it an absolute path. Okay, so that is the requirement here and not a relative path. And also here this is just slash app where our actual application is running. So this is where actually the mirroring happens. So let us see how can we actually implement this. So now we can just stop this particular container. So within my Docker command, I can also specify a volume over here, which also can be used as a bind mount. Okay, so if I can say -v, so we need to give an absolute path and not a relative path. Okay, so to give the absolute path, we can use the PWD, which stands for present working directory, and that will fetch the absolute path. Okay, so when you just do a PWD here, so this is the path which you can actually give. So you can either hard code it or you can just use this variable PWD. Okay, so we can just use that by saying $sign within curly braces PWD. So in case you have any white spaces, like you see that my code, so this contains a white space, right? So we just need to wrap that in quotes. Okay, so we just wrap this PWD in quotes like this, and then we need to specify the path inside the container. So that is slash app, right? So if you remember from our Docker file, we had given the working directory to slash app. So we need to give the absolute path always. Okay, so now if I hit enter, so actually my container was still running, so I can just remove the container and then rerun this. Sorry, my bad, this has to be in common braces and not curly braces. So I'm used to that syntax of that template literal, so that's why. So now if I click on enter, so now our application is running on port 8080. Okay, so one thing which we need to change within our Docker file is to change the start command from npm start to npm run dev. Okay, because this will run the node 1, right? So which will constantly watch our file changes in real time. So whenever we change a file over here, the same file change will happen inside the container as well, and then it will restart our server. So this is the actual concept. So we can just change this to npm run dev and just try to rebuild our image for one last time. Okay, so later we don't even have to rebuild our image for every file change we make. So we can just stop this container and just do a docker remove todo app. Okay, and now we can just rebuild our container saying docker build -d backend dot. Okay, so let's wait for it. So now let's run the same command again over here, and so now this is running in watch mode. Okay, so now let's wait for it to run. So now you see that our application is running. So now if I make a file change, like let's go to the server.ts and just try to change something saying starting server with exclamation marks, and now if I just save this file now and now go back to my terminal, and now you see that it has restarted the server inside the docker container as well, because we had started this in nodemon, and for every file change that we make within our host machine will reflect even in the container as well. Okay, so this is all about bind mounts, how you can mirror the data from our container and our host machine. So we have fixed almost everything, all the problems that we have faced. So there is just one problem that we are facing, like whenever we want to start our containers, we just need to run those commands manually. Okay, so how will it be if I have a particular file, okay, where I have all of the configuration for starting docker containers, and it will just spin up just by writing one single command. Imagine if I have 5 containers, I every time need to run 5 different commands to run those containers. Okay, and also you need to memorize that the command also, or you might need to store it somewhere and then copy paste it. So this is a bit of a hassle, right? So that's where docker compose comes into play. Okay, so basically it is nothing but a file, okay, which will contain all of our instructions to run a particular docker container. Okay, so this file is basically written in YAML format, which I will currently show you. So we can go into the root of our directory, and we can create a file called as docker-compose.yaml. okay, so this structure is actually written in YAML format. So we just need to specify different services for our containers to run, and whenever we run this particular file, all of our containers will be spinned up. So over here we need to start by specifying the version of the docker compose which we are using. So we say version, and this is 3.8. okay, and make sure these are in quotes, in double quotes like this. Okay, and the next thing which we want to write is services. Okay, so currently we have 3 different services. One is our main backend application, then MongoDB, and then Redis. Okay, so we can just store this within services, and we just need to separate this by a semicolon and giving this a tab, which means that this is inside this block. Okay, so we need to write 3 different services. One is for the backend, and then we have the Mongo, and then we have the Redis. Okay, so let's start with the backend. So inside this backend, so we need to generate an image based on this docker file over here. So inside this backend we can specify build, and inside this build we can give this a context. Okay, so basically where exactly our docker file is present, so that is in the same directory, we can give this a dot, and then we can specify the docker file. Okay, and then give this the name of docker file. So now within the same level as our build, we need to give the container name. Okay, so we say container dash name and give this a name of todo app. Alright, and then we need to specify the ports, okay, where this container can be accessed. So we say ports, and inside this we'll take a list actually. So we need to basically map the ports, so that is 8080 to :8080. okay, so the first 8080 is the port inside the container to the outside port where we can access within our host. So basically we just have one port, so we can now go to the next step, that is volumes. So we have basically one particular volume just for the bind mount. So just as I told you, we need to give it an absolute path that should actually point to our project to the same path inside the container as well. So inside docker compose file we can give it an absolute path, and that will be resolved internally to an absolute path. So we can give it a relative path. So we can just say // which is actually a relative path, and then actually this should be inside a list, and then we map that to the containers path. Okay, so :/app. So that's where our app is running inside the container. And next we have is the networks, right? So inside this networks we have one particular network, that is to do network. Make sure you spell this right. And yeah, so this is our backend service. Okay, so we now need to build another service. So here we have the Mongo service and then the Redis service. Okay, so the first thing is we just need to specify the image name. Okay, so since we for the MongoDB container we don't have a Docker file, so we pull the image directly from Docker up. So instead of specifying the Docker file, we specify image over here. Okay, so which image does it pertain to? So the image name is Mongo, right? So we just specify here Mongo, and then we need to give this a container name. So let's call this Mongo again, and then the ports. So by default the MongoDB port is running on 27107, so we just need to map the same port again. So again, this should be in the form of a list, 27017 to the same. Then we can give it a volume, so inside volumes, and this will take in a list again. So we can just give this a volume of Mongo data, and we can just map that inside the container to /data/db. Okay, so that's where our MongoDB is actually data is actually stored. And then finally we have the networks. So this again is in the network of to do network. Alright, so now let's move on to the Redis. So the implementation is same for Redis as well, just as Mongo. So we can just duplicate this, and we can just call this Redis. Okay, and the path is just /data. Okay, just as we saw, and the port is 6379. Alright, so in addition to the ports, we can also specify a command where we can just set the password. Okay, so every time we spin up a Redis server, we need to configure the password. Okay, so I'm not sure if there is a command where you can disable the password. So I didn't find that. So if you can use that. So we can just specify command, and over here we can do a Redis-server, and then give this another thing called as --require password, require pass, and then the password. Okay, so this will set up the password. So once we start a container on this Redis, it will set the password and then start it. Okay, so now we have specified all these three services. Okay, so one last thing is we just need to list whatever the volumes that we are using within these three services. I don't know why this compose file actually wants us to do that, but we just need to specify volumes like this. Okay, it doesn't by default pick it up, so we just need to specify the volumes of Mongo data, and then we have Redis data, because these are the volumes. Okay, so we can just specify like a list like this and give this a colon. Okay, so these are the volumes, and also we need to specify networks. I know this seems a bit redundant, but Docker Compose wants us to do this, so we can just specify the network. Okay, and give us a colon. Okay, so don't forget the colon. So yeah, this is our Docker Compose file. We can now save this file, and we can go to our terminal right now. So we can stop all of our containers. So let's stop all these three: Docker stop, Redis, Mongo, and to do app. And also let's remove them. Okay, so now we have a clean Docker file, so we do not have any containers running. And one thing we need to specify over here within our main backend service is that it depends on this Mongo and Redis. So because it will try to run this particular backend service without Mongo and Redis, so we just need to do a depends on, and we just need to specify the service name, that is Mongo, and then Redis. Okay, so first it will spin up Mongo and Redis, and then spin up this backend service. Okay, so because once we run this backend service and Mongo and Redis are not even started, so it will give us an error. So with that done, we can now save this and now go back and run the compose file. So now to run this compose file, we can say docker compose and then specify up, which means that we want to run this file, and saying --build. Okay, so this will run this particular file, and let's wait for it. So now all of our three containers are currently running, so we can just verify by going to the Docker desktop, and you see that within it creates a folder over here, by the way, so Node.js backend architecture, and you see that these three services are currently running. Okay, so now we can go back to Postman and give this a test. So I'm going to first register a user. So this user is already registered. Let me just try it once again. Okay, so let us go ahead and access a to-do route. Okay, so we can first register a to-do. So our to-do is registered, and now we can access this route, and we are able to fetch all of our to-dos. Okay, so the next time if I just click on send, so now we are fetching it from the cache. Okay, so actually when we fetch it from the cache, we are getting in the form of this data property, and inside that we fetch all of our to-dos. Okay, so this is a bug actually in this application, so never mind. So now we can just go back to our file over here. So we can now see that our cache is found. Before it was null, and now it is found. Okay, so now even though I just close this container and bring it back up, so we should be able to see that. Okay, now if I just close all of these containers, so if I just do a control C, it will stop all these containers as you see over here, and now I can just rebuild this up. Okay, so now I don't have any containers running, so if I just try to hit this also, it gives us nothing is running on port 8080. So now I can just bring this back up by saying docker compose up -- build, and this will build all of our files again, and this will let's wait for it and just check if everything is still working fine. So now you see that our server is running on port 8080. So now if we go back and give this a send, and we are still getting those to-dos, because even though our services are down and then brought up, we are able to still fetch our to-dos thanks to the volumes that we had set up for our MongoDB and Redis. Alright, so this is all about Docker, I guess. So I guess that is it. So I think I have covered all the concepts that related to Docker in this one particular application that we have built, and we have explored all the features in Docker. So I hope this one particular video helped you understand the entire concept of Docker. Why do we need it in the first place, and how does it help in deployments and solve the problem where if it runs in our system, it should also work in any other system. Okay, so this is for this video. So if you like this video, please give it a like and subscribe to this channel for more amazing content just like this in this Node.js backend series. And in the next video, we are going to address another problem when it comes to deployment, which also covers the concept of Kubernetes. Okay, so I'll see you guys in the next video.